Okay, good evening. I'm Seng here. Allow me to just self-introduce. Basically, I'm at the School of Electrical Electronic Engineering of Polytechnic. Okay, I basically lead a division of over 40 academics to drive technology development in collaboration with industries and research institutions in the various domains of electrical and electronic engineering. For myself, I'm also actively involved in our own SP autonomous electric vehicle projects. My current research interests are in machine learning for automatic car number plate recognitions and V2X technology for smart mobility. Okay, let me start with my segment of this webinar for this evening. Okay, allow me to give you a brief history of electric vehicle. Electric cars have been around since the dawn of cars itself. This dates back to the year 1830s, where the first electric vehicle was created. In early 1900s, electric cars were very popular among Americans. We find them in cities like New York, Boston, and Chicago. As many as 1/3 of the vehicles were actually battery powered. We also have electric taxi, dominating over the busy cities at the time as well. Electric cars, compared to the gas power competitors, they were much quiet, easy to maneuver, and they did not release any forward odor. The real competition came in the early 1900s when Henry Ford built the Model T car, which let the driver drive further and faster. And this eventually led to the downfall of the electric car. The Model T car was an affordable car made for the mass market. There were proper production line being assembled, used to assemble the car. And there were many cars of the Model T being made available for the mass market. Now these are some pictures of the early electric vehicles. At the top left-hand corner, you see our first ever electric vehicles. So this was the electric vehicles in the 1830s. Then we have this picture of a German electric car in the early 90s. Another picture of an electric car built by Thomas Parker. Thomas Parker was an inventor who actually held patents improvements in lead-acid batteries and dynamos. And in the center here, we have Thomas Edison taking the picture with an electric car in 1913. Thomas Edison is an inventor famous for inventions like the light bulbs, the motion pictures. Okay, and the last picture here shows electric taxis, in the year 1896 to 99. So these are basically how electric vehicles look like in the 1800s and the early 1900s. And you can see them to be quite different from the electric vehicles that we see today. I mentioned earlier that there was a decline of the electric vehicles in the early 1900s. Now this was mainly due to petroleum, was very abundant and was very cheap. And there has been technology improvement in gasoline powered cars. So Henry Ford's vehicle was one example, and these gasoline powered cars can travel faster and further. In fact, by the time of 1930, there were no more electric cars seen on the roads. Decades later, however, things change. We see oil prices went up sharply after the 1970s oil crisis. Air pollution became worse and worse with more and more gasoline-powered cars. And electric vehicle came back to the attention. By the time of 1990s, we have many car makers coming out with their electric vehicles version. There were also hybrid electric vehicles being released, and this can serve as a better alternative as compared to pure EVs. So how do these electric vehicles look like in the 90s? We have some pictures here from General Motors, a Ford Ranger, a Toyota Prius, a Toyota Rifle, a Honda EV Plus. Now, Honda EV Plus was rather special at that time. Alright. Electric vehicles in the 90s typically were running on lead acid batteries. But Honda EV Plus was different. It was using nickel metal hydride batteries. In fact, there was something like 24 nickel metal hydride batteries within this Honda EV Plus. And another special thing about this Honda EV Plus is that it was not sold. It was only for leasing basis. So car owners who wants the Honda EV Plus will have to lease from the company on a 3-year lease basis. And they are not sold. And there were very limited edition of this car being produced, something like only about 340. Okay, then we have the Nissan Ultra EVs. Again, there's something special about this. At the era when EVs were running on lead acid batteries or nickel metal hydride, this Nissan Ultra EV was using lithium ion batteries. Alright, it was using lithium ion batteries produced by Sony corporations. So it basically made itself rather different, okay, from the electric vehicles in this era. So to sum up, I would say that electric vehicles up to the late 90s, main characteristics is that they are using either lead acid batteries or nickel metal hydride batteries. Lithium battery was very expensive, and the electric vehicles typically have limited range, alright, 80 to 200 kilometers. And that is considered rather small, rather short range. Alright, and the battery lifespan also does not last long. And electric vehicles were very expensive. Okay, even after subsidies are given by governments. And they were in no way could compete with internal combustion engine cars in terms of both performance and price. In the 90s, Singapore Polytechnic already has a vision to go green. So we were actually involved in EV education and technology development since 1997. One of our significant projects at the time was this zero emission bus. We teamed up with the Trans Island Bus Service and a private company called Green Fuel Resources to actually convert a diesel engine driven bus into an electric one. Now this diesel engine driven bus was a Nissan civilian electric bus. You can see it is a 19-seater bus, and it was basically converted to an electric driven bus. And we basically piloted it or put it on trial for 8 months. The collaboration with the bus company Trans Island was very important at that time. For the information on Southview, Trans Island bus service is basically today's SMRT bus. As you can see on the bus body itself, there's emphasis on Singapore first zero emission electric bus. Wordings like for a cleaner environment. So emphasis on zero emission already starts in the 90s. Now this bus was also featured in our newspaper at the time. So if you look at the interior of the bus, alright, the batteries used was basically zinc air batteries plus advanced lead acid batteries. For this bus, the diesel engine was being replaced with an electric drive system. Zinc air batteries has the characteristics is that the zinc itself is very cheap and it is in abundance. And zinc air battery is rechargeable as well. The Singapore Polytechnic experience of able to basically convert a diesel bus to electric bus basically starts from our experience of converting ICE car to electric. So this project was completed before the bus, and this basically gives us the experience on how to basically do the conversion for the electric bus. Now, Singapore Polytechnic, being an education institution, would like to really publicize sustainability to the main public. So at that time, we also produced a multimedia CD-ROM. Now this was an era where CD-ROM was popular with school students. So we actually developed a CD-ROM in a period of 12 months, and that was back in 1998. So the CD-ROM itself was filled with educational stories, pictures, video clips, and text on electric vehicles that are used in the 19th and 20th centuries. And at the time, alright, we are probably the world's first multimedia CD-ROM that captured the history of electric vehicles. Apart from conversion of diesel bus to electric and production of multimedia CD-ROM, Singapore Polytechnic also ventured into solar electric vehicle developments. We built our first solar electric vehicle in the period of 1998 to 1999, and this solar car actually participated in the World Solar Challenge in Australia. Our solar car participated in the race where it stretches from Darwin in the north of Australia to Adelaide in the south, over a distance of 3,000 kilometers. Fast forward 10 plus years later, we built our second version of our solar electric vehicles, and we participated in the Shell Eco Marathon Asia. Following that, we participated in the World Solar Challenge again, and this time we also received generous funding from the Singapore Power Group for our students and staff as well as alumni to participate in this race. So you can see how our solar electric vehicle basically evolved over the years. Now this was basically the challenger class of the solar electric vehicles. We decided to challenge ourselves further. The World Solar Challenge has another class of vehicle called the cruiser class. So in 2015, we decided to participate in the cruiser class of the World Solar Challenge. In the cruiser class, you will have to build a vehicle to minimally seat 2 persons. So the car itself will look more like an ordinary car, and you can see solar panels, all right, fill up the top of the car. And we have a very big team involved. So we have the solar, we also have the cruiser class in the 2017 race as well as the 2019 race. So you can see that Singapore Polytechnic was very much involved in electrifications of vehicles. In the last 6 years, all right, we have also ventured into autonomous electric vehicle developments. Now we have this SAE, which stands for the Society of Automotive Engineers. So in the SAE, we have different definitions for the automation levels of autonomous car. First, we have the level 0. Basically, it is an ordinary car with no driving automations. That is level 0. Then we have level 1. The automation basically is in terms of the car able to provide steering or braking support to the drivers. For level 2, it is similar, except that the automation includes both steering as well as braking acceleration support to the driver. So that is level 2. For level 3, the car will be able to drive by itself, but under very limited conditions. And it is very, very particular about the conditions. It will not operate unless all the required conditions are met. So that is level 3 for automation level of autonomous car. Okay, we are level 4 and level 5, and this definitely the cars are much more autonomous as compared to the higher levels. So for Singapore Polytechnic, our journey into autonomous electric vehicle developments starts with the e-scooter and the go-karts. That was something like 5 years ago. Thereafter, we move on to phase 2, where we basically acquire an electric buggy. In phase 2, we basically spend efforts to convert the electric buggy to a drive-by-wire system. So what do you mean by drive-by-wire system? It is basically retrofitting the electric buggy so that it can be electronically controlled by the computer software. So we have achieved that in phase 2. So our vehicle was able to move over limited areas over our campus. It is equipped with cameras to see vehicles in front. It also has localization abilities using LiDAR sensors. In phase 3, we move to autonomous safety vehicles for campus surveillance. We expand the capabilities of our autonomous buggy. We have trained it to be able to navigate a large area of the SP campus. It is also equipped with vision system that is able to recognize number plates as is seen on the roads, and it is able to self-navigate. So this is basically our phase 3 of our autonomous vehicle. Okay, so this is basically our autonomous vehicle in actions. Now you may ask why I choose to show this video. Okay, this was taken during the period of COVID. I believe it was something like 2 to 3 years ago. Alright, it was an event where the Minister of Education, Minister Chan, visited SP, and we actually invited him to sit in our autonomous buggy together with our principal, Chief Executive Officer of Singapore Polytechnic. So currently, our autonomous vehicle development continues. We focus on 5G network integration. We focus on digital twin simulation. We focus on V2X, vehicle to everything. And we also look at solar power to improve the operating time of the vehicle. Our school here is also into industry collaboration with the industries, so that we can enhance our teaching materials with the assistance of the industries. So one example we have here is Inchcap and SP co-developed electric vehicle technology courses. So we have an MOU signing. We also have collaboration with SP Group, where they basically have EV chargers on the campus. This basically allows our students to see firsthand on how EV charging is done, and we also use this as a way, as a tool to teach our students. Singapore Polytechnic is also one of the parties in this multi-parties MOU signing on the National Vocational Certification Program called NEST, National EV Specialist Safety Course. So Singapore Polytechnic is also a provider for this course, where we focus on initiative to upskill and certify professionals in EV maintenance and servicing. We also have collaboration with Siemens, where we have the Siemens Digital Experience Center having software that allows us to do vehicle design. So this is basically how we strengthen our curriculum as well as our project works by working closely with the industries. Okay, now let's move back to electric vehicles. Okay, so let us take a look at the electric vehicles in the last 15 years from 2010 onwards. Basically, I would say that Tesla Motors has changed the face of electric cars. Tesla started with this Roadster model. Now this is basically a battery electric vehicles sports car. Thereafter, it produces a Model S, Model X, Model 3 and Model Y. Now Model 3 was an affordable model of the Tesla, while the Model Y was a crossover SUVs based on the Model 3 chassis. So electric vehicles produced by Tesla was able to run faster and can go for longer distance, right, than any other brands of hybrid or pure EVs could. Autopilot and AI technologies were also introduced in the electric vehicles. The success of Tesla actually encouraged the other automakers to basically build electric vehicles. So we actually see more modern EVs on the market. In Europe, we have the BMW i3, the Renault Zoe, the Volkswagen e-Golf. In Japan, we have the Nissan Leaf, the Toyota RAV4, the Mitsubishi i-MiEV EV. In China, we have the BYD E6, the NIO, ES6, ES8. We also see a special type of EV called the fuel cell EV onto the markets, where we have models from Toyota, Hyundai, Honda, and Mercedes. So what are fuel cells electric vehicles? Fuel cell electric vehicles basically has a propulsion system very similar to electric vehicles, where the energy are stored as hydrogen gas in a tank on the vehicle. And this is converted into electricity by the fuel cell on the vehicles. Unlike conventional ICE vehicles, there were no harmful tailpipe emissions. In fact, what is produced from a fuel cell EVs are basically water and heat. So it is environmental friendly. Okay, so these are some of the modern electric vehicles. In the US, we have the Tesla, the Model 3. I'm sure you have seen this in Singapore roads as well. In China, we have BYD Han. Japan, you have Nissan Leaf. Europe, you have the Renault Zoe. Europe, you have the BMW i3s. So you can see modern electric vehicles available in different continents, and they are sold worldwide as well. Electric vehicles of today also has many smart features. So allow me to show a 3 minutes plus video on some of the smart features of a typical electric vehicles. So I pardon our audience here. This short video is recorded in Mandarins, but I will basically give a summary in English after the video is over. So let us watch this short video to see smart features in electric vehicles.
关闭全部车窗。
车窗关了。
好，就是在车内的话呢，我们可以去呼叫 Nomi 去实现一些功能上的一些操作。但是 Nomi 的话，它也有一个声源的一个分区控制，比如说。
Okay, so what I like to emphasize here is, okay, modern electric vehicles has features like using voice control. So this example you've seen here was using voice to close a window.
向我主驾呼叫它 ，Hi Nomi，
我来了。
帮我开窗。
好的。
然后它识别到是我主驾的指令，我这一个音区的指令，它只开我这一边的窗子，那其他窗子是没有变化的。所以说，您在车内的话呢，就是可以去呼叫 Nomi 去做任何的事情，除了驾驶之外的，比方说音乐、空调、车内的按摩、通风、车窗，这都是可以去语音来进行打开的。因为现在车内的按键是非常非常少的，所以说呢，我们也是希望通过语音的交互来实现一个这种在驾驶时的一个这种避免安全。
So you see that in electric vehicles today, you have many big panels, but very few, physical buttons for you to press. And with the use of voice control, it actually minimizes the number of physical buttons you will see in a modern electric vehicles.
隐患的这种情况，因为毕竟咱们开车的时候双眼要注视前方嘛，那如果你边开车边看屏幕，其实是非常危险的。所以说我们语音功能就是这样去产生的，而且还有一个好处就是，现在这个交互的速度和车内芯片的算力嘛是非常快的，那就是源于这个车内的一个这种车载芯片的算力。所以说呢，我们的一个语音交互速度和车机的反馈能力，其实基本上就是你一语即达，就可见即所得，所见即所得。包括说像我们的这个辅助驾驶的一些这种功能的操控，都可以在这个位置去进行调节。那这边是有个面容识别的，等于说呢，就是咱们每个人开车的时候，比方说一家子3个人都开车，不同的驾驶习惯、不同的座椅姿势，只要你调完之后，它就会记入到您目前登录的账号里面。那下次再上车，面容识别到是您的面容之后，它就会帮您去还原相应的一些这种习惯和座椅姿势。 所以这就比较方便。那么
Okay, so this EV also is equipped with facial recognitions. Okay, because for electric vehicles or for car, sometimes you may have different drivers. So when different drivers in the family drives a car, they may need different setting of the car seats or the adjustment of the mirrors. So with facial recognitions, this can become automatic. Family A comes to sit in a car at the steering wheel, it will adjust its car seat, its mirror accordingly. So these are one of the smart features the car has.
换电池方面呢？换电是吧？在这个位置，我们有一个闪电按钮，您点一下，然后这个位置就会去显示出我们这附近所有的这个换电的一个站点的位置。您看这现在全中国像上海这个城市是非常多的已经超过150座换电站。那我们举例子，像这块这个换电站，我们点进去之后呢，我们一是能够看到这个里面电池的储备，第二的话呢是能够看到多少人在排队。因为这个和平时那种传统的充电站和加油站是不一样的，因为往往您在去到这种充电站或加油站的时候，我们是不知道这个位置是否是排队的。那这个时候呢，我们都是纯线上实时更新的。一是我知道他什么时候排队，二我可以去估算时间。4个人在排队，那我们这边点击一下，它会自动导航去。我们
Okay, this is a new EV that you see in the video. Basically allows it is charged by basically changing batteries. So this is not so typical in Singapore. So this new EV basically was sold in Shanghai. So there were basically many battery changing stations around. So the dashboard of this EV basically allows one to do planning. When the battery level drops below a certain level, it will basically alert the drivers and give suggestions to the driver. Okay, what is the nearest battery swapping station you can reach, and who is in the queue, and what type of batteries are available for you to swap to. So these are features that's available in this particular brand of EVs. So you can basically, based on the suggestions by the computer, move your EVs to the charging station that is most appropriate to the driver.
我们过去也要15分钟。那我们刚才看了一下，4个人换电，差不多也是15分钟能换好。那这个时候我直接过去，就不至于去排队了。所以说可以去很好的去控制一下我们自己的时间。第二的话呢，就是换电站的好处就是它会有很多电池的配备。有分这种标准续航的电池，也有分这个长续航的电池那我们如果今天万一要去一趟跑个长途跑个远途，那我们可以临时在这个 APP 里面去下单升级成这个长续航的电池。那我们只要去到换电站把这个电池换走，我直接就开到外地，一天只要花50块钱，也不用担心这个成本过高。因为未来不同规格的电池虽然它能量密度不一样，续航不一样，但是电池包的一些尺寸、长宽高，这其实都是一样的，可以直接去做更换。所以未来换电的好处就是可充、可换、可升级。一是快，二呢就是可以去做升级。第三的话，我们就不用担心它的一个续航的衰减，因为凡是从我们换电站里面出来的电池，都是我们做过检测的。那寿命低于90%，其实我们自己就会淘汰。
Okay. Okay, so basically electric vehicle has largely improved in recent years. The price of battery has dropped, and that basically corresponding leads to a drop in car price as well. There has been improvement in the range per charge. You can go longer distance, and improvement in battery technology has led to improvement in the lifespan of the batteries. Electric vehicles are integrated with intelligent control and autonomous driving technology. So electric vehicles are well adapted to become autonomous. It is basically a matter of loading in the right software, assuming that the necessary sensors are already present. In addition to the much lower maintenance and travel costs, electric vehicle is getting more and more competitive, and we see this as something that will continue, a trend that will continue. Now, in an electric vehicle outlook reports of 2021 by Bloomberg NEF, it is estimated that the share of electric vehicle markets basically will increase from 4% to as much as 70% in 2040. Even there were no new incentive policies introduced by governments all over the world. I would say that to achieve carbon neutrality target by 2050, more policy support is still needed to accelerate the adoptions of electric vehicles. So what have we done in Singapore so far? In Singapore Budget 2021, we aim to have 60,000 electric vehicle charging points, both at public car parks as well as private premises by 2030. $30 million grant has been set aside for the next 5 years for EV-related initiatives, and we will increase the affordability of electric cars by narrowing the cost difference between electric cars and internal combustion engine cars. We allow the additional registration fee to be lowered from $5,000 to $0 for electric cars. We adjust the road tax for electric cars so that the mass market electric cars pay similar road tax as internal combustion engine cars. LTA also has launched this EV common charger grants. This is to kickstart the installation of shared charging infrastructures in non-landed private residences. So LTA will co-fund the installation for 2,000 EV chargers, and this scheme is available until 31st of December 2025. Our government also proposes law for EV charging, where it requires new buildings to install chargers. So you can see that in Singapore, we have many initiatives to entice the public to adopt electric vehicles. Electric vehicles basically forms part of the green infrastructure and mobility emerging domains in the green economy. There will be a demand for knowledge and skills in this green infrastructure and mobility, and we see a demand in this area, and we will provide more EV educations or EV related educations. So examples of skills will be related to electric vehicle and hybrid electric vehicle maintenance measurements, or EV charger maintenance, as some of the skills needed for the green economy. Now this slide basically sums up what we will expect to see in the years to come. In 2025, next year, every HDB town will become EV ready. We will see goals of 400 diesel bus being replaced with electric buses. In fact, 60 electric buses have already been deployed in 2021. By 2030, we will actually see 60,000 EV charging points, and half of our buses and taxis will have been electrified. In 2040, we will see all our new cars to run on cleaner energy. we use the word cleaner energy is technologies are developing. So apart from electric vehicles, there may be newer technologies that are equally clean. So that's the reason why, all right, we choose the word cleaner energy, which will of course includes electric as well as any other nascent technology that may come in the years ahead. By 2050, all right, we hope to reduce the maximum land transport emission by 80%. In Singapore, land transport is the third largest carbon emitter, third largest emitter. It basically emits as much as 15% of the total emissions of Singapore. So it is crucial to reduce the transport emissions so that the country as a whole will have a cleaner environment. So apart from electric, what other cleaner energy can we possibly have? Okay, one possibility is hydrogen. Can hydrogen be a key to sustainable transports? So this is, in fact, was even brought out in Parliament as a question to the Minister of Transports, and that was back in 2022. So basically, we already have hydrogen fuel cell vehicles, all right, where the vehicles will have power by combining hydrogen with oxygen from the air. So one good thing about such vehicle here is to refuel is very fast. You just need 5 minutes. It's like driving ICE vehicles to a petrol station to top up. So it's very fast. However, fuel cell technology currently is still not so efficient. To produce hydrogen, 70% of the energy is actually lost in the process of electrolyzing the water. Hydrogen also needs to be stored and distributed at low temperatures and high pressure. And again, this requires substantial amount of energy. So this hydrogen technology is still nascent, but we can see this as a possibility. So what's driving the electric vehicle revolutions? One, of course, is environment consciousness, government policies, as well as technologies. In the market, all right, we basically can have 3 different types of electric vehicles. In the diagram on the left here, we have the conventional vehicles, where you have a fuel tank. You go to a petrol station to top up the fuel tank. The fuel tank will provide fuel for the engine, and the engine will power the car. So the advantage of such a conventional vehicle is that it is easy to refuel, it has a long driving range, and it has a high speed. It is a typical car that most of us are driving today. However, emission is an issue of such a vehicle, and fuel costs are high in today's context. So that is the conventional vehicles. Then you have the hybrid electric vehicles. So for the hybrid electric vehicles, you will still have a fuel tank as well. You have an engine, indicated by the green color portion of diagram. You also have electric motors. So it is basically driven by the engines, while the motors are secondary. There's also a traction battery pack that is used to power the motor. So hybrid electric vehicles has the advantage that it is easy to refuel. It consumes less fuel consumption, and there's also less emission when it is driven by the electric motor. However, there's lesser power of such a vehicle and it is heavier because of the additional parts, the traction batteries and the electric motors. Then we have the plug-in hybrid electric vehicles. So for the plug-in hybrid electric vehicles, same thing. You have the fuel tank, you have the traction batteries, you have the engine, you have the electric motors. The battery pack is larger. There's also a charging port that basically allows the vehicle to be charged externally. The main driver of this vehicle will be the motor itself with the engine secondary. So again, such hybrid vehicles, you don't have to worry about couldn't find a charging station. It is easy to refuel, and you also consume less fuel and there's less emission, especially when it is driven by the electric motors. This is also a very high price vehicle because of additional parts, and you don't have many models to choose from. Lastly, we have the all-electric vehicles. There's no fuel tank here. You have a very large battery and you have a large motor as well. So this is environmental friendly. There's low maintenance because it has a very simple structure, alright, not many parts. The disadvantage is that we may be worried of not enough charging stations. The driving range may be short and you couldn't go very high speeds. And also the weight may be heavy because of the batteries. All electric vehicles, okay, one good example would be Tesla, alright, that make all electric vehicles. We also have brands like BYD or Blue SG, alright, being all electric vehicles. So in order to win the race to electrifications, number one, we have to overcome consumer range anxiety. We have to convince consumers that electric vehicles can go far. Technology has to improve such that vehicles can travel as far as internal combustion engine vehicles. We need to reduce the cost of the EVs. If you look at this chart here, in 2015, alright, battery electric vehicle cost much more than internal combustion electric vehicles. In 2025, the projection is that they are more or less similar already. Okay, they are more or less similar. Because if EVs are too expensive, then who will buy them? Thirdly, we have to look at the charging time. If you have to spend 2 hours charging, then it may not be so attractive to buy electric vehicles. So there must be a way to reduce the charging time. You go to a petrol station and top up, it can be just as long as 5 minutes or 10 minutes. So there must be a fast way to charge. So fortunately, we have available fast charger. In 1 hour, you can get something like 100 plus kilometers. Then we also have level 2 charger. Alright. So in 1 hour, you get about 16 kilometers. For fuel, of course, it is still unbeatable at the moment. In 5 minutes, I can get 500 over kilometers. But technologies are improving. Okay. So the other issue here is, apart from able to charge fast, the other issue here, at least locally here, is availability of EV charger. As you probably have observed, in most car parks, alright, you only have a few lots with EV chargers. So will you have an issue of, you have to fight or you have to wait for the charger to be available before you get to charge your electric vehicles? Of course, there's also a need to have some trade-off, because if every car park lot is to have a charging point, it's going to be very expensive. The electric capacity in the vicinity of car park also needs to be upgraded to allow this. So there are still many issues, but we are basically having steps moving ahead to make it attractive to own an EV charger, to reduce the amount of inconvenience that we have for EV charger. Okay, the key components of an all-electric vehicles. I will divide into 4 components. First, we have the powertrain system. Now, the powertrain system refers to a set of components that functions as power generation and transmissions for moving the vehicles. Then you have the battery pack, which is made up of multiple lithium-ion batteries, as you can see here. Then you have a battery management system, which will continuously monitor the state of the batteries, take necessary measures in case of malfunctioning of batteries. We also have the charging system, where you have a charge port here that allows AC or DC charging. Okay, we also have a control system, alright, which comprises of several electronic control units to control the different subsystems of the electric vehicles. So this is basically the key components of the electric vehicles. Okay, my last slide here, alright, is just to share with you some interesting facts of electric car. So first is, electric cars are not a new concept. So at the beginning of my webinar today, I mentioned that actually electric cars was available around the same time as cars was invented, and that was basically back in 1830s. Alright, electric cars are no longer silent. Alright, people are now basically able to accept electric cars. They are getting more and more popular. Tesla basically has a new feature to keep pets cool if the pets have to stay in the car. Braking add miles to the range. For electric cars or hybrid electric cars, typically when a car brakes, it is basically able to generate electricity to the batteries. So it basically allows you to travel longer, alright, because of the regenerative braking of the car. So that's why we say that braking can add miles to the range. There are more electric car charging points than petrol stations. Okay, in Singapore, how many petrol stations do we have? I would say it is not more than 200 petrol stations. We definitely have much more electric car charging points. In fact, our aim is by 2030, we will have as many as 60,000 EV charging points. So this is an assurance that you need not worry that you cannot find EV charging points. The general public will basically learn to adapt. Okay, especially issues where people are hogging electric charging points after charging is finished. It's a matter of time, right? Where we learn to be courteous for each other, be more understanding, to move our cars away after charging is finished. You can also charge electric car at some petrol stations. In fact, you can power your house for an electric car, although it is not common in Singapore. And in the United Kingdom, you actually have a new electric car registered every 9 minutes. So you can see how well received are electric cars. Okay, so with that, I would like to end my presentation here.